All right, so welcome. We are in section 3 of chapter 2, and we are adding to our toolkit for different derivative recipes. And for this section, we're going to focus on the product rule and the quotient rule. So, to make sure you understand, let's start with the idea that f of x is equal to x cubed, and g of x is equal to x to the power of 5. So notice that we have two functions, f and g, and both are functions of x. The question is, what would the derivative of the product of f and g look like, right? So f of x times g of x, the derivative of that, what would that look like? So let's assume that we have two students and they both take a different path here. So let me go ahead and I'm going to rewrite this. So we have the derivative, and I'm going to plug in x cubed for f and plug in x to the power of 5 for g. So again, we have two different students, and they're going to use two different approaches. We're going to see which one's right. Are they both right, or are they both wrong? So the second student does the following. Okay, so student 1 says, okay, well, let me multiply first, and then I'll take the derivative. And student 2 says, well, wait a minute, I'll just take the derivative of f, then take the derivative of g, and then I'll multiply the result. So let's do that really quickly. So student 1 would go multiply first. So x cubed times x to the 5th is x to the 8th. And student 2 decides to take each derivative first and then multiply. So this would be 3x squared times 5x to the 4th. All right, well, the derivative of x to the 8th is 8x to the 7th. And then we've already taken our derivatives. When we multiply, we would have 3 times 5 is 15. And x squared times x to the 4th is x to the 6th. So clearly, these are not equal, right? So what can we determine? Well, in mathematics, you can both be wrong, but you can't both be right. In other words, if you have separate answers, you can both be wrong, but you can't both be right. So which one of these is the correct way of doing this? Well, we actually know that, well, I'll tell you, I'll put a pin in that for just a second. And let me introduce the two rules. And I will not do, I'm sure this is going to irritate you and make you cry, but I'm not going to do the proofs for the product rule or the quotient rule. So for the product rule, the way we're going to approach this is we're going to have, if you have two functions, f and g, you take f prime times g plus f times g prime. So that's the product rule. We'll come back to the quotient rule in a little bit, but let's practice the product rule. So I've written the rule off to the top right, and we want to find the derivative of h of x equals. So notice that here, if the clever student wanted to, they could FOIL this out, right? They could FOIL it and then take the derivative, which would be exactly what this particular student did. He multiplied first, except they didn't have to FOIL. So that will work. And to go ahead and anticipate the question, if you would like to FOIL that out on your test and then take your derivative, I will not mark that wrong unless I were to say find the derivative using the product rule, right? It's my job to clarify if I want you to use a particular rule. But if I don't clarify, then you are welcome to use the method that you please. I will go ahead and say that you can imagine that if this were, let's say this 5 plus 4x were to the power of 10. I don't think this clever student wants to FOIL all that out. So, but nevertheless, we would need a different method anyway. But let's go ahead and tackle the question. So here's the way I like to tackle product rules and quotient rules. I want to get all of my work out of the way up front, and then I'll just plug everything into the rule. Okay, so the way that I would approach this would be as follows. I would want to label f, and to save time, I'm not going to write f of x or g of x. I'm just going to write f and g. So let's label, what do we want to call f? Well, we'll call f 3x minus 2x squared, and we will call g 5 plus 4x. So now notice that the rule requires that I know f prime as well as g prime. So let me go ahead and do that now. So f prime, g prime. So in this case, f prime would be equal to, we'll say 3 minus, 4x. And g prime would just be equal to 4. So now, notice that I have all of the work out of the way, and I can just plug everything in to the right spot. So let me do that now. So I'm going to plug in f prime for here. So this would be 3 minus 4x. Then I want to multiply that by just g. So that would be times 5 plus 4x. Okay. Plus, let me give myself a little bit of room here. So plus, and let me continue here. So now let's just take f, which is 3x minus 2x squared. And finally, I need to multiply that by g prime, which is just 4. Okay, so notice, I want you to understand that notice that this is the derivative. Now, I agree with you, it's pretty sloppy work, and we do need to clean this up. But you have actually, at the point of substitution, you do have the derivative. It's just your job now to clean up your product, right? To offer a better product to your customer, which in this case is me. So from here, the calculus is done, and all we're going to do is do a little bit of algebra. So we're gonna FOIL this out, and we're going to distribute this, and then we're going to combine like terms. All right, now on your own time you can work out all that, but the result should be negative 24x squared plus 4x plus 15, right? So if you FOIL, distribute, and then combine like terms, here will be your, this is what you'll be left with is your derivative. Okay, so let's go through another one. So again, we're going to find the derivative we're going to use the product rule. And again, something that it can be obvious, but I've seen it plague students for a long time before they realize the obviousness of it. So if your question is, when do I use the product rule versus a power rule, right? Well, notice that you have 3x squared times sine of x. Notice that each factor has a variable. Let me see if I can make it more simple here. Notice the difference between these two problems. In the latter, the one in red, there's no need to use the product rule to take this derivative. But in the former, the one that we're going to do, you would need the product rule. What's the difference? Well, the difference is, notice that there is one of your factors has a variable, sine, but there's no x. There's no variable in your other factor. It's just 3. It's not the same here. Both factors have a variable. So these can be thought of as two functions being multiplied. Ready? Let's go ahead and begin. So let's let f be 3x squared. Let's let g be sine of x. And I like to get all the work out of the way up front. So let's go ahead and find f prime. And let's find g prime. All right, so in this case, starting with f prime, that would be 6x. And g prime, the derivative of sine, is cosine. Okay, I have everything out of the way. I'll write that rule, f prime times g plus f times g prime. And let's do it. Let's just put everything in the right spot and then finish it up. So start with f prime, 6x times g sine of x plus f, which is 3x squared, times g prime, which is cosine of x. All right, well, there's really no need to have parentheses here because 6x times sine of x is just 6x sine of x. And same thing here, 3x squared cosine of x. So there's no negative exponents. There's nothing else. Well, I'll say something in just a second. There's no negative exponents. We have combined all like terms, so I'm happy with this answer. You probably should, if you were to look this up in the back of the book, what you would see them do is factor out a 3x, to which you'd be left with, let's see here, you'll be left with 2 sine of x plus x cosine of x. Nope, did I do that right? Yes, I did. Okay. All right, let's continue. So we're still using actually, I tell you what, if you don't mind, because I'd mentioned this in passing, that, so for example, forget about this problem, we'll come back to it in just a second. Take 3x squared plus 2. Now, let me see, I tell you what, let me make this easier, because I want to get through this really quickly. I just want to show you something. 3x squared. Assume with me for just a second that a student forgot whether they needed to use the product rule here or the power rule here. Right now, hopefully you understand that the power rule is the easier way. So we know that that if this is f, then using the power rule, we can quickly come to the solution that f prime is just 6x. But watch, what if the student forgot and they decided to go about this f times g, let me rewrite, f prime times g. I I've learned the product rule in so many different notations that I sometimes forget which one I just used. Plus f times g prime. Okay, so let's assume that this student said, well, let's let f equal 3, and let's let g equal x squared. Then f prime would equal 0, and g prime would equal 2x. Now, I know that you're already thinking, why would this student go through all this trouble? But remember, they forgot. They didn't know which rule to use, so they decided to use the product rule. But notice, at this stage, when they start to plug things in, we would have f prime, which is 0, times g, which is x squared, plus f, which is 3, times g prime, which is 2x. Do you notice that it doesn't matter? Right? 0 times x squared is 0, and 3 times 2 is 6, so 6x. Either way, whether they chose the product rule or the power rule, they would have arrived at the same answer. So now what I want to do is actually tackle the problem. I will leave this here for just a second before I erase it, but let me read the next example. So we want to find the derivative of y equals 2x cosine of x minus 2 sine of x. So while I'm erasing what's below, see if you can tell me, we have two terms, right? What I'm underlining here. One of those requires product rule, the other does not. So while I'm erasing, see if you, in your mind or out loud, if you're in a safe place, which one would require the product rule. Okay, so hopefully you pointed out what I'm underlining right now does require the product rule. The second one does not. I mean, this is very easy. So let me go ahead and start. So y prime is going to be equal to, well, let me start with the 2x cosine of x portion first. So let me start here. 2x cosine of x minus 2 sine of x. All right, so let's start here. So y prime, let's go through and label. So let's let f be equal to 2x. Let's let g be cosine of x. All right, I just need f prime and g prime. So in this case, f prime would just be 2. And g prime, the derivative of cosine, is negative sine. Okay, so let's go ahead and put everything in the right spot here. So looking up to the top right-hand corner, I have f prime times g. So that's 2 times cosine of x plus, all right, now it's f times g prime, which is 2x multiplied by negative sine of x. Okay, so I'm with you that I need to clean that up a little bit, but let me now go ahead and take the derivative of the 2 sine of x. So that's going to be minus, well, the derivative of sine is cosine, so this is just minus 2 cosine of x. Okay? Very easy derivative. So let me now drop this down because what I have written here is the derivative of the 2x cosine of x. But from that, I still have to minus the derivative of 2 sine of x, which we just found out is 2 cosine of x. Okay, so let's clean everything up. I got 2 cosine of x. That negative symbol in front of the sine can come out front, so that's minus 2x sine of x. And that's minus 2 cosine of x. So hopefully you spot I have 2 cosine of x's, and I take away 2 cosine of x's, so I have none of them. Now I have minus 2x sine of x. All right, and so that is your derivative. So let's do some quotient rule. And I'm going to give you a piece of advice that if you listen to me, I can save you a lot of work. So first, let's notice that the difference between the two formulas, the two derivatives. Obviously, we are now subtracting as opposed to adding, and then we're dividing by g of x squared. So let's make sure we understand all these parts. So we have to be careful with the subtraction because 2 plus 3, 3 plus 2 does not matter. But 3 minus 2, 2 minus 3 matters. So my suggestion would be to pretend or place brackets here at all times. And that'll keep your work nice and neat. Let me go ahead and get started. So we want to take the derivative of a quotient, right? So we have this fraction here. And the way this works is we let the numerator be f, and we let the denominator be g. Okay? So in this case, you and I agree that f would be 5x minus 2, and g would be x squared plus 1. And now I'm going to approach this just like the product rule. Let's get all the work out of the way. So I need an f prime, I need a g prime. So let's go ahead and take those right now. So f prime would just be 5, and g prime would be 2x. Okay, so at this stage, let's plug everything in to our formula. I'm going to rewrite it. I know it's right above, but I don't want any separation here. And I'll use f prime, g prime. I'll use the same notation. The g of x's, f of x's, they can start to clutter a little bit, and sometimes it's hard to read. Okay, so you know what to do. We have all the work done. Let's put everything in the right spot. So f prime is 5 times g is x squared plus 1 minus, now at this stage right now, I would suggest that you go ahead and put some brackets, right? You want to make sure you subtract all of f times g prime. You don't want to lose any negative symbols, in other words. All right, so f would be 5x minus 2, and g prime would be 2x. Okay, and here's the part that if you listen to me, I can save you a whole lot of work. So notice that in the formula, let's look at the denominator. Notice it's g squared, regular g, right? Not g prime, g squared. So my suggestion is, well, let's go ahead and do that. So g is x squared plus 1, right? That's g, and we want to square all of that. So this is g squared. Now, my suggestion is for you to leave this alone. Okay? These textbook problems are quite cookie cutter, and I think you'll now it's possible that we might run into a scenario where we would have to FOIL this out, but let's let the default be, let's leave it alone. Okay? Now let's just simplify the numerator. All right, so obviously I have to distribute. I'll do that now. So that's going to be that's going to be 5 times x squared, so that's 5x squared plus 5 times 1 is 5 minus. Now let's distribute the what comes after the minus symbol. So 5 times 2 is 10. X times x is x squared. And then I have, so it's 10x squared, and then that is a 2, correct? Yes, so 2 times, negative 2 times 2x is negative, negative 4x. Sorry, my eyesight went out for a second. Okay, and let's leave that denominator alone like your professor said. And you can see that if the student didn't heed my advice, if they didn't have these grouping symbols here, they would not have the right answer, right? They would have negative 10x squared, but they wouldn't change that negative symbol here to a positive. Okay? So all I'm going to do right now is combine like terms. So negative 5x squared, that negative symbol has to be distributed to that negative 4, so that's going to be plus 4x. And finally, we have plus 5 all over x squared plus 1 squared. Okay, so we're good. I've just seen students just do things like FOIL this and then factor it again and then FOIL it back. But at this stage, I'm happy. So, because right now we're just working on some basic techniques here. All right, next question. Again, let's read it in its entirety. There is that phrase, equation of a tangent line. So really quickly, just to yourself, if you can recall from the previous video, when I mentioned the association of when you read equation of tangent line, your answer should be in what form? It should be in y equals mx plus b. Okay, that's the game of association. Now, you remember that to get there, we need to have a point and a slope. Now, the good news is they give us the point, negative 1, 1, but they don't give us the slope. So, okay. So, find the equation of the tangent line to the following graph, 3 minus 1 over x divided by x plus 5, and that's at the following point. So here's the graph of f, and here's the point that's of interest to us. And there's some tangent line to that point, and we want the equation of that tangent line. Okay, so first things first, we need a derivative. So what I want to do for you is I want to make sure you understand what I'm about to do. You could, to make this simpler, you don't have to do this, right? You can let f be this numerator and let g be this denominator and just go about this problem the way we did the last one. Or you could rewrite this, okay? For example, if I can combine these fractions, and then nevertheless, I'm not going to waste a lot of time on this pre-calc skill, but I can rewrite f of x as 3x minus 1 over x squared plus 5x. I don't want you to be confused. If you can simplify, you can rewrite f, or you can take the derivative the way it sits. I don't care. It does not matter to me in this problem. So I'm going to take the derivative from here. If you decided to take the derivative from here, we're good to go. It's no problem. But let's get to it. So what's f? What's g? What's f prime? What's g prime? I hope this organization here helps you. It does help me. So f is going to be the numerator, 3x minus 1. G will be the denominator, x squared plus 5x. And I need f prime, which is in this case just 3, and g prime, which is 2x plus 5. Okay, so at this stage, let's plug all of this information into our quotient rule. So it would now look like this. So f prime is 3 times g x squared plus 5x. And that's minus, I'm going to open up some grouping symbols. Okay, so now it's minus what? Minus f times g prime. So f is 3x minus 1, and g prime is 2x plus 5. All over g squared. So in this case, g was x squared plus 5x, and we want to square that. Now, a lot of, well, if I don't, my grad school professors would not like the idea that I have f defined here in one way and then f defined here in another way. They would probably throw something at me. But nevertheless, I hope that it doesn't take away from the problem. I'm just going to continue to use the G notation that we've been using, even though they already defined f to be this. Okay, so all that I need to do is I'm going to simplify this. Right, I got a FOIL here, I got to distribute here, I got to combine like terms. I don't mean to make light of that. I know that that is in and of itself time-consuming and where a lot of mistakes can originate. But I just don't have the time nor inclination to walk through all of that baby algebra pre-calculus stuff. So x squared plus 5x squared. So this here is the derivative. Okay. So let's go back to what we want. So we want the equation of the tangent line to the point. So my point is -1, 1, and my slope is, well, we don't know yet. So let's start there. So does it make sense? I'm going to have to free up some space here. So I'm going to erase this right here. And then I'm going to move my derivative up a little bit. So let's go ahead and label. So since this is f prime of x, again, I know that we said f prime was 3, but that's because we're defining f in two different ways. So, okay. So since this is our derivative, let me pose the question to you. How would I find the slope at this particular point? How would I find m? Well, hopefully by now you're starting to grasp onto the idea that the derivative is that function that will give you the slope. But I need to give the function something first, right? Some type of input before it can give me back an output. So now the question is, well, what do I plug in to this derivative? Well, the x value is -1, the y value is +1. So since the derivative, at least this particular derivative, is only a function of x, then I hope it makes sense that you would have to plug in -1 into the derivative. Well, you could do this on your own time. If you plug a -1 in here, what you would get out is 0. So the slope is 0 when x is -1. Now that makes sense because if you look at the graph, the line running tangent to that point is horizontal, and horizontal lines have slopes of 0. But we're not done. I mean, it would pain me to take off points because you've done such wonderful work. But it wouldn't pain me too much. I would still do it because you haven't actually answered the question. So let's plug in some information. I'm plugging 0 in for m and plugging in my point. So this is y minus 1 is equal to 0 times x. Now that's x minus negative 1. Okay, so x minus negative 1, which is x plus 1. Okay, so 0, the slope 0 being distributed to all of the right side of the equation just means that the entire right side of the equation is equal to 0. But we need it in y equals mx plus b form. All we have to do is move that 1 to the other side. So y equals 1. That's the equation. So this blue dotted line I have here is y equals 1. That's the line that runs tangential to the point on that graph. Okay, so where do we go from here? In the previous section, I gave you the derivative of sine and the derivative of cosine. Notice I didn't give you the derivatives of tangent or cotangent or any of the other trigonometric functions. And the reason being is because we needed the product rule, quotient rule, to be able to do those derivatives. So let me make sure you understand. So what I've listed here is just definition. Definitionally, the derivative of tan is secant squared. The derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. Now, I'm not going to go through this the entirety of this proof, but I just want you to understand that tangent is a fraction, right? It's a quotient of sine and cosine. So if you have a quotient, then you can use the quotient rule, right? F would be sine, G would be cosine, F prime, G prime this is what it would look like. And if you were, that just ends up being cosine squared of x plus sine squared x over cosine squared x. But what is, let's see if you can remember, what is the identity for cosine squared plus sine squared? Do you recall? You're right, it's just that it's a Pythagorean identity. This cosine squared plus sine squared is equal to 1. So do you notice that what you have at that point, I'm working backwards here, is 1 over cosine squared. And now you can see it. So secant is 1 over cosine. So secant squared is 1 over cosine squared. So now you know why, and you could do the same with the other derivatives if you were inclined. But now let's go ahead and proceed. The good news is this is now definitional. So I'm about to take the derivative of secant, and I'm just going to look up here and grab it. So here we go. So we want to find the derivatives of each of these. So y prime, obviously this is a product rule. Actually, yeah. So we have a product rule here, and I will just go through quickly. F is, we'll say, is x. G can be secant x. I need f prime. I need g prime. So f prime would be 1. G prime is looking above at theorem 2.9. G prime is secant x tan x. Okay, so at this stage, all I have to do is put everything in the right spot, right? So I'm going to go ahead and get us to the answer. So plugging all these 4 parts into my product rule gets me to this: x times secant x tan x. Actually, let me write it out, because I don't know. Sometimes I can do it in my head, but sometimes I change the product rule around. I've just done it enough where I can do that without being in too much trouble, but I want to make sure your notes are nice and neat. So this is just 1 times g, so that's 1 times secant, so secant x. And this is f times g prime, so x times secant x tangent of x. Okay, now if you wanted to, you could factor out a secant. Right, if you looked it up in the back of the book, they would probably factor out a secant x, leaving you with just 1 plus x tangent of x. But I'm happy here. Okay, so now let's do, we did part B first instead of part A first. This, we don't need product rules or quotient rules as long as we have access to these definitions. So y prime, the derivative of x is 1. And again, I want to make sure I stress this. Just like you can memorize the derivative of sine is cosine, you can place to memory the derivative of tangent is secant squared x. Okay? Or if you have access to it, right? So if you have a formula sheet, then you can look it up that way. I don't memorize things. I'm brutally honest, I've been doing math for a long time. I probably know these, but I don't memorize things very easily, and I have to look them up. I don't even know if I know my multiplication tables, to be honest with you. But I know how to use this information. I just don't like playing trivial games of memory. So so the derivative of tangent is secant squared, so this is minus secant squared of x. All done. All right, so we'll let this be the last problem of this section. And let's make sure we understand. Well, let's read the question first. So we want to, there it is, find the equation of the tangent line to the graph of f at the following point. So you, on your own time, you could pause the video and try it if you'd like. Hopefully you are starting to pick up on when you read equation of tangent line that means the answer should be in y equals mx plus b form. Okay? If it were to say things like find the equation of the tangent line in standard form, or slope-intercept form, or there's, I don't want to dwell on, I don't want to dwell on this very much, but I can see it tripping you up. So let me write, let me punt for just a second on this problem and just, let's say I write 2y plus 2x equals 4. Now, I could take that equation. I could write that as I'm going to put my x here and my y here. This is what happens when you make up stuff off the top of your head. So 2x plus 2y equals 4. Now, I could graph that, or use that to answer whatever question that I have about that line. That's one form that you could write this. You could also bring the 4 to the left side of the equation, so you have 2x plus 2y minus 4 equals 0. This is another way of writing the same equation. And the last way is I could actually solve for y. Or another way, I could just solve the equation for y. But those are just 3 different forms of the same equation. So if you have to, they each have a name, you know, my standard form or slope-intercept form. They have different names, and each form of that equation is helpful in various ways. Okay, so if you're solving for x, or if you're trying to factor, or if you're trying to solve for y, depending on your application, you might choose one of those different forms. For our purposes, when I say equation of a tangent line, I just want y equals mx plus b. All right, solve for y. So let's go ahead and just jump into this. So clearly what I'm going to need is a point. The good news is I already have that. Pi over 4 is my x value, and 1 is my y value. But I'm also going to need a slope. Now, in order to get a slope, I'm going to need a derivative. Okay, so the derivative of tangent is just secant squared. So that's the good news. Easy derivative. So secant squared x. All right, so let's figure it out. If I want a slope, then I need to plug in some type of input into my derivative. And we're always plugging in the x value. All right? I shouldn't say that. That's a little bit sloppy. We're always, the input, well, I won't dwell on that. So whatever the independent variable is in the domains, that's what we're inputting. So in this case, it's f prime of pi over 4. All right, so that would mean that I have secant squared of pi over 4. Okay, and secant squared of pi over 4 is just equal to 2. All right, beautiful. So now I know that my slope is 2. Okay, so almost there. We need the point slope formula. And then let's start to plug in some information. So plugging in 2, plugging in for slope, plugging in for x, plugging in for y, I arrive at y minus 1 is equal to 2 times x minus pi over 4. All right. Now, to my engineers, to my science people, I know you like to turn pi into decimal equivalent, or not equivalents, but decimal values, or something of that nature. But listen, this is not engineering. So, and I have not given you a margin of error. So, if you turn pi into any type of decimal, it might be a great approximation of the answer, but you're wrong. You need to leave pi alone. Pi should be in my answer. So if I distribute my 2, I would have y minus 1 is equal to 2x minus, well, that's 2 pi over 4, which is, what do we got, pi over 2. And then I know I need to add 1 to both sides. Listen, this is the last problem. Pay attention to the form of this answer. So if I add 1 to both sides, I have 2x minus pi over 2 plus 1. Leave it alone. I know you want to grab your calculator and try to combine these two, okay? But you can't. well, you can, in the sense that you can write 1 as 2 over 2 and write it that way. But you can't turn, what I mean is you can't add these two and then turn them into some type of decimal, and then write that a decimal approximation here. I will have to just mark it wrong. You'll be able to do that in mathematics once somebody tells you the margin of error they're willing to accept, okay? I don't know, are we baking pizzas? Are we firing missiles? I don't know what we're doing with this equation, so I'm not going to start rounding things until somebody tells me what they're willing to accept in my rounding. I will see you in the next video.